Types of clamps used: C-clamp, U-clamp, screw clamp, hacksaw frame and blade. The hand hacksaw is used along with a blade to cut metals of different sections. It is also used to cut slots and contours. Solid frames. Only a particular standard length of blade can be fitted to this frame. Adjustable frame. Different standard lengths of blades can be fitted to this frame. The most commonly used type. It gives a better grip and control while sawing. Hacksaw blade is a thin, narrow steel band with teeth cut on one edge and two pinholes at the ends. It is used along with a hacksaw frame. Chipping hammer. The chipping hammer is used to remove the slag which covers the deposited weld bead. It's made of medium carbon steel with mild steel handle. It is provided with a chisel edge on one end and a point on the other end for chipping off slag in any position. File. A file or hand file is a hand tool used to shape materials. A file typically takes the form of hardened steel bar, most covered with a series of sharp, parallel ridges or teeth. Most files have a narrow, pointed tang at one end to which a handle can be fitted. Parts of a file. Edge. The thin part of the file with a single row of parallel teeth. Heel. The portion of the broad part without teeth near the tang. Shoulder. The curved part of the file joining tang from the body. Tang. The narrow and thin part of a file which fits into the handle. Handle. The part fitted to the tang for holding the file. Ferrule. A protective metal ring to prevent crack of the handle. Tri-square. Tri-square is a precision instrument which is used to check squareness and flatness of surfaces very accurately. The tri-square has a blade with parallel edges. This blade is fixed to the stock at 90 degrees. Burr slot is provided on the stock at meeting point of blade to accommodate the burr if present on the component to avoid inaccuracy in measuring squareness. Wing compass. Wing compass is used for scribing circles, arcs, and for transferring and setting off distances. Snips. A snip, also called a hand shear, like a pair of scissors to cut thin soft metal sheets. Mallet. Mallet is a shaping tool used for general purpose work like flattening, bending and forming to required shape of sheet metal. These are made of hard wood. When using any metal hammer for flattening the sheet metal, the face of the hammer may damage or leave impression, and therefore mallets are used. Double-ended spanner. It is used to loosen or tighten nuts. In welding process, the spanners are used to fix the regulator on to the gas cylinder valves, hose connector and protector on to the regulator. Carbon steel wire brush. A carbon steel wire brush is used for cleaning the work surface from rust, oxide, other dirt etc. prior to welding and for cleaning the inter-bead weld deposits after chipping off the slag. Finally, the tongs. A pair of tongs is used to hold hot work pieces and to hold the job in position.
So far, we have learned about the materials and tools needed for gas welding process and the care and maintenance to keep the hand tools in good working conditions. Before we begin our exercises, we must understand three things clearly. 1. The different types of welding. 2. Types of joints. And 3. The different positions in welding. Now, let's take the first one. Types of welding. There are two types of basic welds: groove weld or butt weld and fillet weld. Now, let's see the different types of welding joints: butt joint, corner joint, edge joint, lap joint, and T-joint. Now, what is welding position? The position of the welding joint line and weld face with reference to the ground axis indicates the welding position. The basic welding positions are flat or downhand position, horizontal position, vertical position, vertical up and down, and overhead position. Now, let's start our welding exercises.
Butt joint welding. Now you can see the test specimen with V-groove. The two halves of the test specimen is ensured in the same plane by checking with scale. The C-clamps are used for tack welding test piece in position. The root gap is ensured by filler wire of appropriate size. The test specimen is tack welded to the test table by tack welding. The V-groove is cleaned using wire brush for removal of any rust, oil and grease. You can see the welder with protective devices like welding shield for protection and safety before commencement of welding. The 60 to 80 amps current and 20 to 22 voltage is set before commencement of the welding. The welding is carried out and the slag is cleaned by chipping and brushing before commencing the hot pass run. You can see the completed butt joint on one side of specimen and the root run on the other side of the specimen. So far, we have seen the various activities involved in fabrication. Now let us see how these activities are being used for fabrication shops with
Welding is the joining of metals or non-metals with the application of heat, with pressure or without pressure, with the application or without the application of the filler metal.
Now let us explain about various activities involved in fabrication. Marking and cutting different angles and geometrical shape on sheet metal. Marking and cutting. Now we are going to see how a weld test specimen is prepared for welding. Here the welder is holding the steel plate on the work table. First of all, the welder starts his work by marking the dimensions with the scale and chalk piece. Now, once the marking is completed, the welder uses the center punch and indents the dimension points. Now the specimen is ready for oxygen acetylene gas cutting. The welder uses all personal protection equipments such as safety shield, gloves, safety shoes, etc. The workman chooses appropriate size of the nozzle for the cutting torch, and the cylinder valves are opened slowly using the key, and he tests the gas flow, also cleans the nozzle for free flow of gas. The oxygen acetylene hoses are connected to the cylinder at one end and to the cutting torch to the other end. Now he opens the oxygen and acetylene control valve in the ratio 1:3, and oxidizing flame is produced. The gas flow is regulated for gas cutting. Now, the flame adjustment is completed and cutting is commenced on the job, and welder holds the torch steadily and cuts in a straight line. Similarly, the positions at the work pieces are changed and the remaining sides of the pieces are cut. Now, the cut pieces are held in the vise and edges of the specimen are ground square using a grinding machine. The perpendicularity of specimen is checked using tri-square for the orientation of the joints. Now the plate is ready for the fit-up. Draw a circle, pentagon and an equilateral triangle as dimensions given in the job drawing using geometrical construction principle or method, keeping O as the center for all these shapes. Construct a circle inside a square. Set the compass for 60 mm radius using a steel rule. Keep one of the pointed end of the wing compass at the punch mark on the square sheet. Draw a half circle clockwise from left to right using thumb pressure. Mark the rest of the circle anti-clockwise from left to right. Mark clearly at the first stroke itself. Construct a triangle inside a circle. Draw the radius of circle as 0.58 into the side of the equilateral triangle. that is 0.58 into 75 is equal to 43.5 mm. Draw the circle with the above radius and mark the center lines JK and ZN. Draw an arc XOY from point N, taking NO as radius and cutting the circumference of the circle at X and Y. Join XY joint YZ. And ZX. Construct a pentagon inside a circle. Draw a circle with O as center by using a wing compass. Name the horizontal center as AB, that is the diameter of the circle. From C as center, CO as radius, draw an arc cutting the circle and name it G. Join points C and G. Now the line CG is one of the sides of the pentagon. Sheet metal folding. Procedure for making sheet metal folding. Take the sheet metal of the required dimension. With the help of a steel rule, draw the elevation and plan of the object. Using scissors, cut the sheet metal along the border. This will give the development of the object. Bend the sheet metal along the drawn line using a chisel and hammer. Place any one portion of the bended part and using wooden mallet, make the angle as 90 degrees. By applying mild force using mallet, make the joints perfect. The job is held by a tong and temporary welding joints are made at all the open-end corners to make the joint perfect. Drilling holes to various diameter in sheet metal using punching machine and twist drills. Take the workpiece and cut the required outer shapes of the metal sheet. Mark the dimensions for various sizes of holes in the sheet. Drill the holes for using of punching machines and twist drills. Check the paper pattern for its correctness in size. Ensure the correct size of the material is given as per paper template. Single rivet. Riveting is a method of joining temporarily by drilling a common hole in overlapped pieces and then fastening them by putting a rivet and hammering. In single rivet, the riveting is made on a single row. A pilot drill is made on the plates so that a small hole is made on the plates. The holes are cleaned with the help of a file. The rivets are placed on an anvil and the plates are placed on the rivets in such a way that the rivets sit exactly on the hole. Using a hammer and a nut, the rivets are made to come through the hole. The protruded ends of the rivets are flattened to join perfect. Double rivet lap joint. In this, the riveting is done in 2 rows. The rivets are placed in the zigzag hole. Using a hammer and nut, the riveting can be done. The protruded ends of the rivets are flattened using a hammer. Single strap butt joint. In single strap butt joint, the plates are butted against each other. Markings are made on this plate for the rivets. Markings are made on the cover plate also. Holes are made on these markings. Cover plate is placed on the butted plates in such a way that the holes sit perfectly on each other. Rivets are placed on the holes and riveting can be done using a hammer and nut. Double strap butt joint. In this, 2 cover plates are used. One plate is placed on the top of the workpieces and another plate is placed at the bottom of the workpiece. As before, marking and riveting can be done. Pipe bending. Unroll the copper tube. Measure the required length with the help of a steel rule. A mark is made on the copper tube. The tube is held on a wheel cutter. The hand grip of the cutter is rotated so that the cutting tool advances and touches the copper tube at the mark we made. Few rotations of the cutter will make an impression on the tube. The process is repeated until the copper tube is of measured length separated from the roll. Pipe bending can be done with the help of a pipe cutter. In the bender, there is a central wheel. Graduations are there in this wheel so that the handle can be turned at any angle from 0 degrees to 180 degrees. The tube is clamped on the bender with the help of the clamp provided at the left handle of the bender. Mark is made at the required angle. The right handle of the bender is moved towards the copper tube so that the tube is held gently between the right handle and the central wheel. The tube is bent till the mark on the tube coincides with the required graduations on the wheel. Thus, the tube is bended to the required angle. Dear folks, we are about to learn an interesting metal joining process, that is welding. Welding is an indispensable method widely used in all types of industries. Shall we learn what is welding?
This welding is broadly classified into two methods, namely fusion welding and pressure welding. In fusion welding, the most widely used applications are the shielded metal arc welding, gas tungsten arc welding, gas metal arc welding, and submerged arc welding. Here we shall study shielded metal arc welding, which is the most versatile and commonly used process in the fabrication industry. Now, what is shielded metal arc welding? It is having a shielding with the help of a flux coating. That is why it is called shielded metal arc welding. It is an arc welding where an arc has to be created for heating the material, for which the welder will have to take the electrode close to the job and he has to withdraw by a mm or so. In the process, the arc is initiated. The flux acts as the shield, thus not allowing the atmospheric air to contaminate the weld pool, and hence the name shielded metal arc welding.
The power sources used for shielded metal arc welding are AC-DC equipments, namely AC transformer, DC generator, AC to DC rectifier. These equipments transmit electrical energy to the workpiece and convert the same into heat for melting the ends of the metal. We use both AC and DC power sources for welding. For good quality welding, we always prefer DC power source. Even for continuous welding, we use the direct current power source. This one is called the rectifier. It was being used in the earlier days. These days, as it is not absolutely rectifying the direct current, we have to go for a generator like this one. This particular equipment is used for converting a high voltage, low current capability of the power into a low voltage, high current capability. Generally, welding is done between 60 and 160 amps in the shield metal arc welding. This is an inverter-based equipment. The equipment is very handy and portable. The welder can take it comfortably to any place and weld. It also has a very low power consumption, resulting in a lot of power saving. Let us know the main tools and accessories used in fabrication welding. They are the bench vise, welding cable, earthing cable, welding holder, welding helmet, welding regulator, chipping hammer, chisel, wire brush, hacksaw blade, hand gloves, grinding or cutting machines, grinding or cutting wheels, leg guard. This is bench vise, which is commonly used in workshops. Vises are used for holding work pieces. They are available in different types. A bench vise is made of cast iron or cast steel. It is used to hold work while preparing the edges of sheets plates and pipes by chiseling, hacksawing and filing. The welding cable's end is always connected to the welding holder. This holder is used to hold the electrode in its jaws. It is made up of copper or copper alloys which have very high electrical conductivity. Now, in order to feed the electrode, a holder is a must. A major portion of the holder is made up of wood. This wood is an insulating material. If there is any electric leakage, it may save the welder from electrical shock. Earth cable is another important cable. It is an important connection for welding. This is an important equipment connected to the welding machine. This is called welding regulator. The welder has got graduations from 60 amperes, 80 amperes, 100 amperes and so on. During the course of welding, the regulator is used to control both the current and voltage. This regulator is important to do the different positions of welding. Welder helmet is a safety and a protective equipment used by the welder during welding. This has two components, the white glass and black glass. A white glass is basically used to protect the black glass from spatters during the welding. And the black glass prevents the ultraviolet rays that emit during welding and protects the eyes of the welder from being injured. This is a GQ4 grinding machine. We use this machine to remove the slag that is coming from welding. We have to remove the slag continuously. For this purpose, we use a 4-inch grinding wheel. AG5 machine is used for cutting. Cutting wheel machine is a heavy-duty machine. We use this machine for cutting mostly very high abrasive tools. These are all some of the wheels and discs that we use in this machine. So, this is a typical grinding tool. The grinding wheels are made up of abrasives. This is a cut-off wheel used and grinding wheel for cutting purpose. This is a grinding wheel and both are 7-inch in diameter. The selection of the equipment depends on what you want to cut. Depending on the thickness, the RPM, the power in watts and so on, you can save time while cutting the huge amount of metal using the appropriate equipment. This is a grinder helmet used for protecting the eyes of wheels. A grinder will always use this helmet so that the metal particles do not get into the welder's eyes. The chisel is used for chipping operation for removing excess metal. chipping hammer is used for removing the patters and also to clean the interpasses of the welded layer. This is a metallic brush. We have to clean the weld bead with this wire metallic brush. It cleans the welded surface from layer to layer. Electrodes are the sources of filler metal that are used to melt and join the ends of the base metal. Shall we know them? The three types of electrodes used in metal arc welding are cellulosic, rutile, basic. Let us know more about the types of electrodes, their uses, and where they are applied. Cellulosic electrode coatings are made up of materials containing cellulose, such as wood pulp and flour. The coating on these electrodes is very thin, and the slag is easily removed from deposited welds. The coating produces high levels of hydrogen and is therefore not suitable for high-strength steels. Rutile electrodes are general-purpose electrodes having coatings based on titanium dioxide. These electrodes are widely used in the fabrication industry as they produce acceptable weld shape and the slag on deposited welds is easily removed. Strength of deposited welds is acceptable for most low-carbon steels, and the majority of the electrodes in this group are suitable for use in all positions. Basic or hydrogen-controlled electrode coatings are based on calcium fluoride or calcium carbonate. This type of electrode is suitable for welding high-strength steels without weld cracks, and the coatings have to be dried. Electrodes, especially low hydrogen electrodes, need to be baked in equipment named as electrode baking oven. Electrodes are placed in trays and heated to 300 degrees centigrade for 2 hours to prevent or remove moisture entrapment in electrodes. After baking is completed, these electrodes are transferred to holding ovens which are maintained at a temperature of 150 degrees centigrade and used for welding at this temperature. There are 4 types of joints used in fabrication welding: lap joint, T-joint, corner joint, butt joint. Lap joints. In lap joints, one plate is placed parallel over the other plate with a lapping length as per requirements. T-joints. In T-joints, one plate is placed perpendicularly over the other plate lead to form a T-type of joint. Corner joints. In corner joints, one plate is placed perpendicular or at an angle to other plate with inside corner edges of plates are placed together. Butt joints. In butt joints, one plate is placed adjacent to the other plate with a small gap in between called root gap. Plate fillet weld position. Now let us study the welder's qualifications. This is very important because unlike other trades, here the welder has to be qualified enough according to the international standards. The basic requirement for the welder is to start with a fillet weld qualification. This 4 position, that is 1F, 2F, 3F, 4F, is the most easiest and the most simplest of all to start welding. Now, in 45-degree tilt, the welder is going to weld in downhand position. Now, next position is called 2F. 2F is called horizontal position welding. Now, the weld axis is horizontal and electrode axis also horizontal position, and we are going to weld the joint like a fillet weld. So, this will be called 2F horizontal position fillet welding. Now the third position is called vertical up. Now this is a vertical joint where the electrode is kept at the bottom of the test piece and the welder is going to drag this vertical straight up by welding against the gravity. So this is called 3F position. (4F) overhead position. In most of the project, the welder may weld something above and weld metal come against the gravity. The electrode is kept over the head like this and the welder tries to do this electrode manipulation. This is called 4F welding. Let us see the different positions involved in true welding. Flat position, horizontal position, vertical position, overhead position. Flat position. In flat position, welding object is below the welder and welding electrode is placed downwards while welding. Horizontal position. Now, in horizontal position, welding object is placed in the plane parallel to the welder and welding is carried on x-axis from left to right or vice versa. Vertical position. Vertical position in which the welding object is placed in the plane parallel to the welder and welding is done in y-axis, that is, from bottom to top. Overhead position. In overhead position, as the name indicates, welding object is placed over the head of the welder and in reverse to flat welding, electrode is placed vertically upwards during welding. Oxyacetylene welding. Oxyacetylene is a method of joining metals by heating them to the melting point using a mixture of oxygen and acetylene gases. The plates are marked and cut to the dimension. The plates are flattened using a hammer and anvil. The edges are filed using a file to remove burrs as well as to make the surface smooth. Place the edges of the workpiece in a flat surface and then bring them close for welding. Hold the blowpipe nozzle at an angle of 60 degrees to 70 degrees and fill a rod at 30 degrees to 40 degrees. Tags are made at the ends. Welding is made to the full length of the workpiece by filling the material in the weld area. By holding the workpiece with the help of tongs, burrs are removed using chip hammer. Inside corner joint. In this, the plates are tacked after setting them in 90 degrees to each other. The perpendicularity is checked by using a tri-square. Then, welding is done throughout the length. Inside corner joint. Welding. One plate is placed on a horizontal plane and another plate is placed in a vertical position. The workpieces are adjusted for a perfect T position. Then tacks are made and welding is done. Lap joint. Two plates are taken. One plate is lapped over the other. After making tacks, the workpieces are placed in a vertical position and welding is done. outside corner joint. One edge of the plate is placed on another edge of the plate so that the corner angles are 90 degrees. Tacks are made and welding is done. Corner joint welding. Now let us see how the corner joint is made. One test piece is placed at the corner of the other test piece is maintained. The required 20 to 22 volts and 60 to 80 amps is set for 2.5 millimeter diameter electrode. The completed welding is cleaned for slag by chipping and brushing. Lap joint welding. Now you can see how the lap joint is prepared. The specimens are placed on test table and one piece is placed over the other one test piece. The 60 to 80 amps current and 20 to 22 voltage is set before root run for 2.5 millimeter dia electrode. The welding is done at 45 degrees to weld axis and drawn as stinger bead. The completed root welding is cleaned for removal of slag by chisel. The completed weld joint is measured for throat size and leg length using weld gauge. One plate is placed on a horizontal plane and another plate is placed in a vertical position. The workpieces are adjusted for a perfect T position. Then tacks are made and welding is done. The weld bead is cleaned by chipping and brushing to remove the slag. Now the test piece is tack welded to test table in a vertical position. The appropriate current and voltage is set to start the root run, and the root run is carried out. You can see how the weld metal is deposited on the test piece. Before starting the next run, the weld is cleaned to remove the slag. Once the cleaning is ensured, the welding is continued from the end point of the previous run. The root run is completed. The weld bead is cleaned by chipping and brushing to remove the slag. Following exercise. Fillet and cutting on MS sheets. The mild steel plates are taken. Markings are made as per the drawing to make the required profile. Using chisel and hammer, the pieces are cut. The burrs are removed and edges are made square. The pieces are placed against each other to check the perfectness of the fitting. Fabrication of bracket. Study the drawing and take the workpiece. Drill the holes for using of punching machines and twist drills. Check the paper pattern for its correctness in size. Welding the metal piece by using arc welding. Inspect the bracket as per dimension as shown. Production of drill gates. The drawing is studied. Work pieces are cut as per the dimensions in the drawing and straightened using hammer. First, the outer part of the drawing is fabricated using arc welding, and the fabricated part is checked for perpendicularity using tri-square. The inner part of the drawing is fabricated using arc welding. The fabricated inner and outer parts are placed as per the drawing and welding tags are made. Using arc welding, the grill is fabricated.